You think you have seen the universe. You look up on a clear night, away from the city lights, and there it is. Thousands of stars, the pale river of the Milky Way, maybe a planet or two. And you think, that's it. That's the cosmos. Well, I want to tell you something that took the best minds of the 20th century decades to accept, and it is this. Everything you can see up there, every star, every galaxy, every wisp of glowing gas, everything that has ever been photographed by any telescope ever built, adds up to about 5% of what is actually out there. 5%. The other 95% is dark. It does not shine. It does not reflect. We cannot see it. We cannot touch it. And until about 90 years ago, we did not even know it was there. So when you say you have looked at the universe, what you have really done is glance at the crumbs on the table and mistaken them for the feast. Now, I know how that sounds. It sounds like the setup for some mystical nonsense, some invisible energy, crystal healing, ancient astronaut garbage, and I want to be very clear right at the start. That is not what this is. I have spent a good part of my life fighting that kind of thing, because the universe is astonishing enough without inventing lies about it. What I just told you is not a belief. It is a measurement. It comes from watching how galaxies turn, how light bends, how the whole thing has been flying apart for nearly 14 billion years. The darkness is real, and it is measured, and it is the single largest fact about the place we live. So stay with me, because I want to walk you into the biggest secrets this cosmos is keeping. And I want to do it honestly, brick by brick, so that when we get to the strange parts, you will know they are true, and not just because I said so. Let us start from the ground, literally. Start with the thing under your feet, the Earth. For almost all of human history, this was the whole story. The Earth was the center, the stage, and the heavens were a painted ceiling that turned above us. And you cannot blame our ancestors for thinking so, because it certainly looks that way. The sun rises, crosses the sky, sets. The stars wheel overhead. It takes a real act of intellectual courage to stand on a thing that is spinning at 1,000 miles an hour, hurtling around the sun at 67,000 miles an hour, and say, "No, wait, I think it is us that is moving." Copernicus said it. Galileo went to the mat for it. And every time we have taken one of these steps, the lesson has been the same, and it is a hard lesson, and it is this. We are not the center. Not of the solar system, not of the galaxy, not of anything. And every time we have humbly accepted that, the universe has rewarded us by turning out to be far larger and far stranger than the comfortable little cosmos we thought we lived in. So here is the first thing I want you to feel, really feel, not just nod along to. And that is the sheer scale of it. Our sun is a star, an ordinary one, not the biggest, not the brightest, a perfectly average yellow star, and it is so large that you could pour 1,000,000 Earths into it. Light. The fastest thing there is, 300,000 kilometers every second, 7 times around the Earth in the time it takes to say the word. Light takes 8 minutes to reach us from the sun. So look at the sun, and you are seeing it as it was 8 minutes ago. Now here is where it gets strange, and I mean that literally, because this is the first door I want to open. When you look out into space, you are not looking out into the present. You are looking into the past. There is no way around it. The light needs time to cross the distance, and the distances are so enormous that the light arriving in your eye tonight left its source long, long ago. Let me make that concrete, because it is one of the most beautiful facts I know, and people rush past it. The nearest star beyond the sun is a little over 4 light years away, so its light left it 4 years ago. Fine, you say, 4 years, that is a while. But go further. The bright stars in the constellations. Some of them are hundreds of light years off, so you are seeing light that left before your great-grandparents were born. The Andromeda galaxy, the nearest big galaxy to our own, the faint smudge you can just make out on a dark night. That light left Andromeda 2.5 million years ago. 2.5 million. When that light began its journey, there were no human beings. There were our distant ancestors, walking upright on the plains of Africa, and they looked up, and they did not have a word for what they saw, and the photons that are landing in your eye tonight were already halfway here. You cannot look at the night sky and see the universe as it is. You can only ever see it as it was. The sky is a time machine, and every telescope is a kind of archaeology. And this is not a poetic flourish. This is the working tool of my entire profession. When astronomers point the biggest telescopes at the most distant objects, they are deliberately looking backward in time, because those faint far specks show us the universe as it was when it was young. We can see galaxies as they were when the cosmos was a fraction of its present age. We are, in a very real sense, watching the history of everything replay itself, because the light is still on its way. So the next time somebody tells you time travel is impossible, you tell them we do it every single night, with our eyes. Now let me build the next brick, because I promised you darkness, and it is time to make good on it. In the 1930s, there was a Swiss astronomer named Fritz Zwicky, a difficult, brilliant, cantankerous man who called the people he disagreed with spherical bastards, on the grounds that they were bastards, no matter which way you looked at them. And Zwicky was studying a great swarm of galaxies, thousands of them, all bound together by gravity, whirling around each other. And he did a very simple thing. He measured how fast they were moving, and then he added up all the mass he could see, all the stars, all the glowing gas. And he asked the obvious question: is there enough gravity from all this visible stuff to hold this swarm together? Because the galaxies were moving so fast that they should have flung themselves apart long ago, like a merry-go-round spinning so hard the children fly off. And the answer came back, and it was not close. There was not nearly enough visible matter. There should have been something like 10 times more mass than he could see, holding it all together. Zwicky called the missing stuff Dunkelmaterie, dark matter. And then, for about 40 years, almost everybody ignored him. And here is where I have to tell you about a scientist I admired enormously, because this is one of those moments where the whole field turned on a single careful person doing honest work. Her name was Vera Rubin. In the 1970s, Vera Rubin and her colleague Kent Ford were not trying to overturn cosmology. They were doing something that sounds almost boring, measuring how fast the outer parts of spiral galaxies rotate. Think of our own galaxy, a great pinwheel of stars. Common sense. The same common sense that works for the solar system says the stars near the center, where most of the mass is, should whip around fast, and the stars way out at the edge, far from all that mass, should drift slowly, the way distant Pluto crawls around the sun while Mercury races. That is what gravity does. That is what should happen. And Rubin measured it, star by star, galaxy by galaxy, patiently, carefully. And it was wrong. The stars at the edge were not slowing down. They were moving just as fast as the ones near the center, as if there were a great invisible reservoir of mass, wrapped around each galaxy like a halo you cannot see, tugging on those outer stars, keeping them from flying away. Now here is where it gets strange. Vera Rubin did this over and over, for galaxy after galaxy, and it was always the same. Every spiral galaxy she looked at was sitting inside a vast, dark, invisible cocoon of matter that outweighs all the stars by 5 or 6 to 1. She did not set out to prove Zwicky right. The data simply forced her hand. And that is the thing about real science that I want you to carry home with you. It does not care what you were hoping to find. Rubin followed the numbers, and the numbers said the visible universe is a rounding error. The galaxies we admire, all that starlight, that is the foam on top of the wave. The wave itself is dark, and you want to ask. I know you do, because I asked it too. Well, what is it? What is the dark matter made of? And here is the honest, uncomfortable, wonderful answer. We do not know. We have known it is there for half a century. We have measured its gravity 1,000 ways. We have watched it bend light. We have watched it sculpt the largest structures in the cosmos. We have found it wherever we have looked. And we still cannot tell you what it is. It is not made of ordinary atoms. We are quite sure of that now, because ordinary atoms leave fingerprints, and the fingerprints do not match. It is some kind of matter we have never held, never made in a laboratory, never directly seen. It goes through you, right now, as you sit there, a soft, invisible wind of it passing through your body, through the earth, as though the earth were not there. And we are hunting it. There are experiments a mile underground, in old mines, shielded from everything, waiting in the dark for one of these ghost particles to bump into an atom and give itself away. So far, mostly silence. This is not a solved problem. This is a live wound in our understanding, and I find that not frustrating but thrilling, because it means the biggest thing in the universe is still a secret, and somebody in this room, maybe, is going to be the one who cracks it. Let me pause here and do something that I think every honest person who talks about science ought to do, and that is to tell you about a time I was wrong, and about how the being wrong is not a bug in this whole enterprise, but the very engine of it. When I was a young man, starting out, one of the first real problems I worked on was the planet Venus. Now, Venus, in the popular picture of the day, was thought to be a kind of tropical paradise. A warm, wet, swampy world under those thick clouds, maybe teeming with life. Very romantic. And there was a puzzle, because Venus was giving off far more radio energy than a warm swamp should. And a lot of clever people tried to explain that away with complicated ideas. And what turned out to be true, what the evidence forced us to accept, was much simpler and much more terrible. Venus is not a paradise. Venus is a furnace. Its thick atmosphere of carbon dioxide traps the sun's heat in a runaway greenhouse effect, and the surface is hot enough to melt lead, hot enough to glow. Nearly 500 degrees, no swamp, no life. A vision of hell, wrapped in beautiful clouds. And I will tell you why that mattered to me for the rest of my life. Because that same greenhouse effect, carbon dioxide trapping heat, is operating right here, on our own world, in our own air, right now, and we are the ones adding the carbon dioxide. Venus was a warning written in the sky. So do not ever let anyone tell you that studying other worlds is a luxury, a distraction from problems here at home. Sometimes the other worlds are the only place you can go to see your own future clearly. Now I want to build the next brick, and this one is about you, personally. Because we have talked about the darkness out there, and I want to talk about the light in here, about what you are made of and where it came from. Because the answer is one of the great secrets, and it is stranger and more intimate than anything in mythology. Here is the question. Where did the atoms in your body come from? The iron in your blood, the calcium in your bones, the oxygen you are breathing right now, the carbon that makes up the very structure of you? These atoms did not always exist. They were made. And to understand where, we have to go back to the beginning, or as close to it as we can get, when the universe was young. Very young, in the first few minutes after its birth. It was almost unimaginably hot and dense, and out of that furnace came the two simplest elements: hydrogen, the lightest of all, one proton, and helium, and a whisper of a couple of others. That was it. That was the entire chemistry set the young universe had to work with. Hydrogen and helium, and essentially nothing else. No carbon, no oxygen, no iron, no gold, none of the stuff that makes up rocks and oceans and living things. So here is the puzzle. If the early universe made only the two lightest elements, then where did all the rest come from? Where did the carbon in your cells come from when the universe was not born with any? And here is where it gets strange. And this is my favorite fact in all of science. So let me lay it out with care. The heavier elements were built inside stars. A star is not just a light in the sky. A star is a nuclear furnace, a place where hydrogen is crushed together under gravity so fiercely that it fuses. Hydrogen into helium, and then, in the biggest stars, helium into carbon, carbon into oxygen, oxygen into neon and silicon, on and on up the ladder, each element forged in the crushing heart of a dying star. And when one of the truly massive stars reaches the end, when it has built a core of iron and can go no further, it collapses in a fraction of a second and then detonates. A supernova, briefly outshining an entire galaxy of 100 billion ordinary stars. And in that explosion, in that unthinkable heat and pressure, the very heaviest elements are forged and then flung out across space. The gold, the silver, the uranium, scattered into the dark like seeds. Those seeds drift for millions of years, mix into great clouds of gas, and eventually some of that enriched cloud collapses and forms a new star. And around that new star, a disk of debris, and out of that debris, planets. And on at least one of those planets, out of those second-hand atoms, life. So follow the chain, because I want you to feel the weight of it. The nitrogen in your DNA, the calcium in your teeth, the iron in your blood, the carbon in every cell. Every single one of those atoms was manufactured in the interior of a star that lived and died before the sun was ever born. You are, quite literally, made of the ash of dead stars. When you look up at the night sky, you are not a spectator looking at something foreign and far away. You are looking at your own origin. We are star stuff, contemplating the stars. We are a way for the cosmos to know itself. And I do not say that to be pretty. I say it because it is a fact, checked and measured and confirmed. And it is more astonishing than any story any culture ever told about where we came from. And I have to give credit here to another scientist who was told she was wrong, because the pattern keeps repeating, and it is important. Her name was Cecilia Payne. In 1925, as a young woman doing her doctoral work, she analyzed the light of the stars and came to a stunning conclusion: that the stars are made overwhelmingly of hydrogen and helium, the simplest elements, far more than anyone believed. And a senior, respected astronomer reviewed her thesis and told her the result was clearly impossible, and pressured her to soften it, to call it spurious. And she did. A little, being a young woman in a field run by older men. And then, a few years later, everyone realized she had been right all along. She had read the composition of the stars correctly, before anyone else, and been talked out of trusting her own data. So let that be a second lesson, right alongside the being wrong is good lesson. Sometimes being right is not enough. Sometimes you have to hold your ground against the whole weight of respectable opinion, because the universe does not consult the experts before deciding how to behave. Now, we have built up a lot of bricks. We have the scale. We have the time travel of light. We have the dark matter. We have the stellar origin of the atoms in your body. And you can feel, I hope, the shape of a building starting to rise. But I have been avoiding the biggest brick of all, the one at the very bottom, the one everything rests on, and it is time. Where did all of this come from? Not the atoms. We did those. The whole thing, space itself, time itself, the universe. And here we come to the deepest secret. And the honest thing to say is that we understand a great deal, and that at the very edge, we hit a wall. And I want to show you both the understanding and the wall. Here is what we know, and it is remarkable that we know it at all. The universe is expanding. This was discovered by Edwin Hubble at the end of the 1920s, and it is one of those facts that quietly rearranges everything. When you look at distant galaxies, you find that they are almost all moving away from us. And the farther away a galaxy is, the faster it is receding. Now, that sounds at first like it makes us the center again, everything fleeing from us. But it does not mean that at all, and this is subtle. So stay with me. The galaxies are not flying through space away from a center. Space itself is stretching, everywhere, all at once, carrying the galaxies along with it like raisins in a rising loaf of bread. Every raisin sees every other raisin moving away. There is no special raisin. The expansion looks the same, no matter which galaxy you are standing in. And here is the move that changed cosmology forever. And it is so simple a child can follow it. If everything is flying apart today, then yesterday it was closer together, and 1,000,000 years ago, closer still. And if you run the film backward, far enough, everything you see, every galaxy, every star, all the matter and all the space between it, was squeezed together into a region of incredible heat and density. And at some moment, nearly 14 billion years ago, that expansion began. We call it the Big Bang, which is a terrible name, because it was not an explosion in space. It was the swift expansion of space itself, from a hot, dense beginning. And you do not have to take this on faith, because it left a fingerprint, and finding that fingerprint is one of the great detective stories of the 20th century, and here is where it gets strange in the most human way possible. In 1964, two young physicists at Bell Labs in New Jersey, Arno Penzias and Robert Wilson, were working with a big horn-shaped antenna, trying to do some careful radio astronomy, and they kept picking up a faint hiss, a background noise coming from every direction in the sky, day and night, all year round, no matter where they pointed the thing. And they were meticulous, and they were annoyed, and they tried to get rid of it. They checked their equipment. They ruled out the city, the military, every source they could think of. and there were pigeons nesting in the antenna and pigeon droppings inside it, and they thought, maybe it is that. So they cleaned it out. They evicted the pigeons, scrubbed the antenna, and the hiss was still there. It would not go away. And what they had stumbled onto, without meaning to, without even knowing what it was at first, was the afterglow of the Big Bang itself. The cosmic microwave background, the heat left over from the birth of the universe, cooled by nearly 14 billion years of expansion down to a faint whisper of microwaves, filling all of space, arriving from every direction, because the birth of the universe happened everywhere at once. Two men cleaning pigeon droppings out of an antenna had accidentally taken a photograph of creation, and they won the Nobel Prize for it. That is how science actually happens. Not with grand pronouncements, but with two people who cannot get rid of an annoying noise and are honest enough not to sweep it under the rug. So we have a genuine, tested, fingerprinted account of the universe expanding and cooling from a hot, dense beginning. That is not a guess. That is as solid as the ground you are standing on. But now we come to the wall, and I promised I would show you the wall. And here it is. We can run the film back to a tiny fraction of a second after the beginning, and our physics holds. But at the very first instant, at the beginning itself, our equations break. They give nonsense answers, infinities, the mathematical way of saying we do not know. What came before the Big Bang? What lit the fuse? What set the whole thing in motion? And here I have to be completely honest with you, because I would be ashamed to be anything else. We do not know. There are ideas, beautiful, serious, mathematical ideas, about the very beginning, about whether time even had a before, about whether our universe is one of countless others. But we do not know. We are standing at the edge of the deepest question there is, holding a lantern, and past a certain point the lantern light simply stops, and there is darkness, and in that darkness is the answer to why there is something rather than nothing. And I do not find that comforting. I find it electrifying, because a universe that has already told us all its secrets is a museum, and a universe that still holds the biggest secret of all, right there at the beginning, waiting. That is an invitation. Now let me turn the telescope around, because there is a secret that is not about the far edge of space or the first instant of time. It is about something much closer. Something that might be looking back at us, and it is the question I have spent more of my life on than any other. Are we alone? Look, we have established that our sun is an ordinary star, one of a few 100 billion stars in our galaxy, and our galaxy is one of a few 100 billion galaxies in the observable universe. Do the arithmetic and it staggers you. There are more stars in the cosmos than there are grains of sand on all the beaches of the earth, and we now know. This we have actually confirmed, that most of those stars have planets. Planets are not rare. They are the rule. There are more worlds out there than we can count. And the same physics that built the atoms in your body, the same chemistry, is operating on all of them. So the question is not idle, and it is not science fiction. It is one of the most rigorous questions we can ask. In all that immensity, on all those worlds, did life arise anywhere else? And if it did any of it ever look up and wonder, the way you are wondering right now? We do not know the answer, but we can be honest about what we do and do not know. And that is where a man named Frank Drake did something clever back in 1961. He wrote down an equation, not to give the answer, but to organize our ignorance, to break the impossible question into pieces we could actually try to measure. How many stars are there? How many have planets? How many of those planets could support life? On how many does life actually begin? How many go on to develop intelligence? And of those, how many build civilizations that send signals out into space? And for how long do those civilizations last before they fall silent? String those factors together and you get an estimate of how many communicating civilizations might be out there right now. And the beautiful, maddening thing is that some of those numbers we now know quite well, and others we have not the faintest idea about. And so the answer ranges from we are one of millions to we are utterly, cosmically alone. Both are still on the table. Both. And here is where it gets strange, and this one has haunted physicists for 70 years. If the universe is so vast, So old, so full of stars and planets and time. Nearly 14 billion years of it. Then the galaxy should have been colonized many times over by now. Even at slow speeds, a persistent civilization could spread across the whole galaxy in a few million years, an eye blink compared to the age of the cosmos. So the great physicist Enrico Fermi, over lunch one day, listening to his colleagues casually agree that the galaxy must be teeming with life, asked a simple, devastating question. Where is everybody? If they are out there, where are they? Why is the sky silent? We have been listening. I helped build some of that listening, pointing radio telescopes at the stars, straining for any signal, any hint of an artificial whisper in the noise. And so far, silence, a great silence. And nobody knows what the silence means. Maybe life is rare. Maybe intelligence is rare. Maybe civilizations destroy themselves not long after they learn to broadcast. And that possibility, I promise you, should keep you up at night, because we are a young civilization that has just learned to broadcast, and we have also just learned to build weapons that could end us. The silence might be a warning, or maybe they are out there, and we simply have not learned how to listen yet. We do not know. And anyone who tells you they do know, in either direction, is not doing science. They are doing wishful thinking, and the universe has never once cared what we wish. I told you I would tell you about a battle I fought, and here is the one I am proudest of, and it ties all of this together. There was a spacecraft called Voyager 1. We launched it in 1977, and it flew past the giant planets, sending back pictures no one had ever seen, and then it kept going, out toward the edge of the solar system, out into the dark. And as it was leaving, in 1990, with the sun shrinking behind it, I argued. And it was not an easy argument to win. Some of the engineers thought it was a waste and a risk to the cameras. I argued that we should turn the spacecraft around and take one last photograph. Not of a planet, not of anything scientifically useful, they said. A photograph of the Earth, from 4 billion miles away. And we did it. And in that photograph, the Earth. Everything, everyone, every king and every war and every love story and every cruelty in all of human history. The Earth is less than a single pixel, a pale blue dot hanging in a shaft of scattered sunlight, a mote of dust suspended in a sunbeam. That is us. That is the entire stage of everything we have ever done. And I wanted that picture taken because I believed, and I still believe, that there is no better cure for the delusion that we are the center of the universe, no better argument for kindness than to see how small and how alone and how precious our world really is against the enormity of that dark. So let me gather the bricks, because we have built the whole building now, and I want you to step back and see it. We live on a pale blue dot, one ordinary planet, orbiting one ordinary star, in one ordinary galaxy, made of atoms forged in the deaths of earlier stars. And that ordinary world, and everything we can see from it, is 5% of what exists. The rest is a darkness we can measure but cannot yet name. The light we see when we look up is old light, showing us the past, so that the sky is a museum of everything that has been. The whole cosmos is expanding from a hot beginning nearly 14 billion years ago, an origin we have photographed in the afterglow, but whose first instant hides behind a wall our physics cannot yet climb. And scattered across the countless worlds out there, life may be common, or we may be the only ones. And the silence, so far, refuses to say which. Now here is the thing I want to leave you with, and I am not going to soften it, because you did not come here to be comforted. Every generation before us looked up and told themselves a story that put human beings at the center, that made us the reason, the purpose, the point of the whole production. And every single time, without exception, when we actually looked, the universe turned out to be under no obligation whatsoever to make us feel important. It is bigger than our stories. It is older than our fears. It is stranger than our myths, and it keeps its biggest secrets, the dark matter, the first instant, the great silence. Not out of cruelty, but out of sheer indifference to whether we ever figure them out. The universe is not trying to be understood. It owes us nothing. And yet, here we are. A clump of star ash on a wet rock, And somehow this particular arrangement of dead star atoms has woken up and started asking questions, started measuring the invisible, started reading the light of the beginning off the noise in an antenna, started turning a spacecraft around to look back at its own home and weep at how small it is. That is the real secret, the one underneath all the others, and I want you to carry it out of here tonight and turn it over on the drive home. In all that dark, indifferent immensity, on this one pale blue dot, the cosmos grew a set of eyes and a mind, and began, slowly and stubbornly and against all its own vastness, to understand itself. We are the universe's way of knowing it is here. We may be the only such way for a very long way in every direction. And if that is true, if we really are, in this vast dark, the rare and fragile place where the cosmos became aware of itself, then the question is not whether the universe cares about us. It doesn't. The question is whether we will care enough about that one improbable candle of awareness to keep it burning, because the darkness is patient, and it is not finished with its secrets. And so far, we are the only ones who have shown up to ask.